Continuing on with example B, this figure is a cylinder. A cylinder does not have any pointed sides or planes that meet, so there are no vertices, there are no edges, and the base is a circle. Our next figure is a cone. We have one vertice, which is point N. We have no edges, and our base in this case is a circle. Letter D, this shape is a triangular prism. There are 6 vertices, U, V, T, W, Y, and X. There are 9 edges, 3 around the top, TV, VU, and UT. There are 3 sides, TW, UX, and VY. And then there are 3 along the bottom, WX, XY, and WY. The next example, we have these nets, and we need to take this and say, if we folded it all up, what shape would that be? Well, the bases here are triangles, so that would be a triangular prism. Letter B, our base is a square, sides are triangles, so that would be a square pyramid. And letter C, there we have a triangle, so that would be a triangular pyramid. And letter D, if you took that and folded it up, that would be a cylinder. For example 3, you want to say what each of these cross sections would be. If we had that plane that passed through, that would be a triangle. Example B, if we passed a plane through there, we would have a circle. Example C, if we passed a plane through there, we would have a hexagon. And example D, if we passed a plane through there, it would be a triangle. Planes of symmetry are 3-dimensional symmetry. Like for this, if I cut it in half, the top half and the bottom half would match up, so that would be a plane of symmetry. Since the top of the circle has infinite lines of symmetry, there's actually infinite lines of symmetry there. Letter B, I'm going to draw this as best I can. You would have one line of symmetry that divided that into top and bottom. You would have one plane of symmetry, that divided that into front and back. You would have one plane of symmetry that cut that into a left and a right. And then you actually have 2 diagonal lines of symmetry on the side, planes of symmetry, sorry. So there are 5 planes of symmetry. Letter C, you would have one plane of symmetry that would divide the shape like that. Second plane of symmetry that would divide it like that. And a third plane of symmetry that would divide it like that. And a fourth plane of symmetry that would divide it, it's kind of like front and back. So there are 4 planes of symmetry. Here, a cone will have infinite planes of symmetry, and this would have, I'm not sure I got them all, this would have 5 planes of symmetry. 1, 2, 3, 4, and 5. And then this shape is a little bit different. You would have one that divided it top to bottom, one front to back, one that divided it left to right, and then I think you would have 2 diagonals on the corners here from the bottom front to the back left, and from the front top to the bottom back. So that would have 5 planes of symmetry.